Hi folks, this is Dr. Carter. Today we're going to be talking a bit about faults and mountain building. We are here in beautiful Lakeview, Oregon. California's a couple miles to the south here. You're looking east that way. This is Highway 395 behind us. And so the thing I'm really excited about here, and what you're going to see on the time-lapse video from the road, is some shots of us basically driving along the escarpment of the fault. But what I love about this is, so what you're looking at here is a textbook quality normal fault escarpment. You kind of see there's like a hillside here. Something gets very steep, and there's no river cutting it. There's nothing really that seems like it could be a powerful agent of erosion. And then you look above there, just between us and that L, if you can spot it. And what you see is you go from sort of a flat hillside, a little sort of terrace there, to something a much steeper hillside. I'm gonna see if I can get a shot of this without putting myself in the path of traffic here. Yeah. And like most faults, it's not just a single strand. There's usually a couple faults all sort of taking up some of that strain there. This is awesome. Let's see. Not sure if I'm going to wander in the streets. Good idea here, but yeah. I mean, this is just one of those places where, like, when you know what to look for, it stares at you. So that little bench up there, then the sun steepening, that is textbook normal fault action. You find these in the Wasatch Range of Utah. You find them in along Lake Baikal in Russian Siberia. You find these on the edges of the African Rift Valley. And that's kind of what we are tectonically in, is something a little bit akin to the African Rift Valley. And we're going to see many features as we drive up Highway 395 that look like things, a little bit like things that you might find in the African Rift Valley. Though, in contrast to the Rift Valley, which is kind of spanning the equator in mostly tropical latitudes, we are here in a healthy temperate latitude, and it's probably about, I think we're about 42 degrees north or so here. So we're going to definitely see a bit of different vegetation. Fun, and the sort of expression of it here is not just a single rift valley, but a series of valleys that we've been driving through on Route 140 for the last hour and a half. Little blocks of tilted crust, and these tilted bits of crust that sort of tilt and extend. All this is powered by an unusually shallow asthenosphere in this region. We're probably seeing something related to some kind of break-off event associated with the Mendocino Triple Junction, several hundred miles to our west, taking place in this larger region. We're going to see it all the way out to, for probably the next couple of days, we're going to see various expressions of this sort of the Great rifting of things. It's I'm still trying to figure it out. It's one of those things, yeah. So, yeah, and so you can kind of see there's some other beautiful mountains to the west. You also notice it's a lot cloudier to our west. This is your textbook rain shadow effect, where most prevailing winds and storms come from the west, and as they're forced up over the mountains, as we've described earlier, the moisture condenses, and you get precipitation and condensation on the windward side, and on the leeward side, as the air descends, its capacity for moisture increases, and so the air is fairly dry out here in this region. We're also at about 3,000, 4,000 feet up, so it's still nice and cool even on this early January or July day, or June day. Days are sort of starting to fade here. So, all right, take a look, enjoy the video. We're going on a drive in a moment.